Good morning, my dear students. I am K. Padma, Junior Lecturer in Chemistry. Present I am working at Government Junior College, Kavur, Guntur district. Today I am going to start our first year chapters. In first year, today I am going to teach you 9th chapter, that is S block elements. In S block elements, the differentiating electron enters into S orbital. That's why these are called S block elements. And we all of you know that the maximum capacity of S orbital is 2. It can accommodate only with 2 electrons. That's why this S block is divided into first A and second A groups. S block elements are classified into first A and second A groups. Now, first I will start first A group elements. Now, what are the elements in first A? First A group elements are also called alkali metals. First group metals are also called alkali metals because these metals and metal oxides of these metals, when dissolved in water, they release hydroxyl ions in the solution. That's why they are basic in nature. That's why these are called alkali metals. We can also decide the alkali nature of these metals by putting the litmus paper in the solution, which turns red litmus paper to blue. So these are alkali in nature. That's why these are called alkali metals. All of these are metals only. The next, what are the elements present in first A group? Lithium, sodium, potassium, rubidium, cesium and francium. These are the elements present in first A group. Lithium, sodium, potassium, rubidium, cesium and francium. Francium is the radioactive element. Now we shall see the atomic numbers of these elements. The atomic number of lithium is 3 and sodium is 11. 11 plus 8, 19, 19 plus 18, 37, 37 plus 18, 55, 55 plus 32, 87. These are the atomic numbers of these alkali metals. And in all these alkali metals, the differentiating electron means the last electron. For example, in lithium, the third electron is called differentiating electron. This differentiating electron enters into S orbital. See its electronic configuration: 1s2, 2s1, and this is 2s2, 2p6 and 3s1. This is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4p6 and p6 and 5s1. Now I am writing the electronic configuration showing that the differentiating electron enters into S orbital. See students, this is the outer electronic configuration of these elements. In lithium, see the differentiating electrons enters into 2s1, and in sodium here it enters 3s1, and potassium it enters into 4s1. Like that the differentiating electron enters into s orbital. And the last one is francium is the radioactive element. Here radon, the atomic number of radon is 86. So the last electron enters into 7s1. Now all of these you see 3s1, 4s1, 5s1, 6s1, 7s1. That's why their outermost electron configuration is given as ns1. The general electron configuration is ns1. So they usually show +1 as the oxidation state. Now coming to these elements, as you move from top to bottom, this is first a group. As you move from top to bottom, the atomic size gradually increases. Why this atomic size is increases means from element to element, ఒక మూలకం నుంచి మరొక మూలకంలోకి మనం వచ్చే కొలది కొత్త కర్పూరం అనేది యాడ్ అవుతూ ఉంటుంది. సో లిథియంలోకి వచ్చేసేసరికి this is the nucleus and this is the first shell and this is the second shell, 1 2. This is about lithium. And coming to sodium, third shell enters, and coming to potassium, fourth shell enters, and coming to rubidium, fifth shell enters, coming to cesium, sixth shell enters, and coming to francium, seventh shell enters. So like that as you move from top to bottom, there is an increase in the number of shells one by one. That's why the atomic size increases from lithium to francium. And then next, as there is only one electron in their outermost orbit, they are ready to give off that electron. That means they are highly electropositive. That means they act as good reductants. ఇవి మంచి క్షేకరణ కారకాలు అనమాట. అంటే అర్థం ఏంటి, అవి వాటి యొక్క బాహ్య కక్షలో ఉన్నటువంటి ఒక్క ఎలక్ట్రాన్ని ఇచ్చివేసి చర్యలో పాల్గొంటాయి. అందువల్ల వీటిని మంచి క్షేకరణ కారకాలు, ఇంగ్లీష్లో దే ఆర్ యాక్ట్ యాజ్ గుడ్ రెడ్యూసింగ్ ఏజెంట్స్ అంటారు. సో ఎప్పుడైతే అవి ఒక్క ఎలక్ట్రాన్ ఇచ్చేసినాయి అనుకోండి, వెన్ ఎవర్ దట్ ఇట్ లూజెస్ ఎలక్ట్రాన్, ఇమీడియట్లీ ఇట్ గెట్స్ పాజిటివ్ ఛార్జ్. సో lithium gets Li plus charge and sodium gets sodium Na plus charge, potassium, rubidium and cesium, and the formation of this charges is increasing in the following order. Because of the small size lithium, it can't give its electron immediately because that electron is strongly attracted by the nuclear charge. So lithium is the least reactive and cesium is the most reactive. So the order of their reducing property is in this order. Next, we shall discuss what are the general properties or what are the physical properties of these first group elements. Physical properties. Almost all these metals are silvery white and soft. Silvery white and soft. All these metals are silvery white and soft, and their as you move from top to bottom, their atomic sizes increases and they have low IP values. With increasing the size, they have low IP, and these metals are very reactive. That's why, because of their high reactivity, the metal sodium, it is stored in kerosene, but whenever it is exposed to air or whenever it is put in water, immediately it reacts with water with vigorous and it forms sodium hydroxide and it liberate it forms immediately sodium hydroxide and it liberate hydrogen also. It liberates hydrogen also. So because of its high reactivity, sodium is always stored in kerosene. Whenever it is exposed to air, immediately it catches oxygen in the air and it is converted to oxides and peroxides and with moisture also it takes this water and immediately it converts to sodium hydroxide and releases H2. So we can say these metals are alkali in nature because of the formation of this hydroxide. Here see sodium is get oxidized. Here Na becomes NaOH. Oxidized means addition of oxygen. Here there is Na, but here in addition to Na there is oxygen. So in this manner we can say that here sodium is oxidized. Here sodium is oxidized. Sodium oxykaranam చెందింది. And H2O, here H2O is get reduced. ఇక్కడ నీరు అనేది క్షయకణం చెందించబడినది. క్షయకణం అంటే అర్థం ఏంటి? హైడ్రోజన్ అన్న కలపాలి, ఆక్సిజన్ తీసివేయాలి. సో ఇక్కడ ఆక్సిజన్ వెళ్ళిపోయి H2 వల్ల మనకు H2గా మిగిలిపోయింది. సో బికాస్ ఆఫ్ దిస్ హై రియాక్టివిటీ sodium metal is always stored in kerosene. And coming to because of their high IPs and their densities, and their density is mass per volume. We can say or we can define the density is mass per volume. So with increasing the atomic numbers, the densities decreases from top to bottom. However, potassium is lesser denser than sodium. Potassium is less denser than sodium, rubidium and cesium. Though with increasing the atomic number, atomic size is increases, but the density is it becomes reduced. Thereby they have low melting and boiling points. They have low melting and boiling points. And we can say almost all these metals they give color in the oxidizing flame. Here the lithium it gives crimson red color, and sodium gives yellow color. Potassium, rubidium and cesium. Potassium gives lilac or pale violet, and rubidium is red violet, and cesium gives blue violet. How these are giving these types of colors means, we all of you know that these elements they have one electron in their outmost orbit. That electron, when you supply heat energy, the heat from that flame it excites this differentiating electron which is NS1. The heat that excites this differentiating electron to higher energy levels, and when that electron come back to its original state, it releases that absorbed energy in the form of light. There we are getting these types of colors. So almost all alkali metals are giving color in their oxidizing flame. Once again I will just revise these physical properties. See the students, almost all these alkali metals are silvery white and they are soft, and their atomic size increases as you move from top to bottom, and they have, with increasing the size, the nuclear charge is very less on the outmost electron present in the outmost orbit. That's why their energies are very less as you move from top to bottom. As they have low ionization energies, but their melting and boiling points are decreases because the density decreases. We all of you know that the density is mass per volume. However, potassium is less denser than sodium. So we can represent the densities in this following order, and they have low melting and boiling points because of that increased atomic size, and almost all these elements they give color in the oxidizing flame. వీటి యొక్క బాహ్యకక్షలో ఉన్నటువంటి ఒక ఎలక్ట్రాను మనం సప్లై చేసినటువంటి హీట్ ఎనర్జీని తీసుకొని అది హయ్యర్ ఎనర్జీ లెవెల్స్కి వెళ్ళిపోయి తిరిగి ఒరిజినల్ స్టేట్కి వచ్చేటప్పుడు అది కలర్స్ని ఎమిట్ చేస్తుంది అనమాట. అది ఎమిట్ చేసిన కలర్స్ ఈ విధంగా అబ్జర్వ్ చేయబడ్డాయి. లిథియం వచ్చేసి క్రిమ్సన్ రెడ్ ఇస్తుంది, అండ్ సోడియం వచ్చేసి ఎల్లో కలర్ ఇస్తుంది, పొటాషియం వచ్చేసి లైలాక్ ఆర్ పేల్ వైలెట్ కలర్ ఇస్తుంది, రుబీడియం వచ్చేసి రెడ్ వైలెట్ ఇస్తుంది, అండ్ సీజియం వచ్చేసి బ్లూ వైలెట్ కలర్ ఇస్తుంది. సో ఆల్ దీస్ ఆర్ అబౌట్ ద ఫిజికల్ ప్రాపర్టీస్ of these elements, and they exhibit the common oxidation state as a +1, and their reducing property decreases in this order: lithium, sodium, potassium, rubidium and cesium. This is the order of their reducing property. That means lithium is the least reactive and cesium is the highest reactive. Because why it is? Because means lithium, because of its small size, it can't give that outmost electron immediately. That's why lithium is least reactive. దీనికి చర్యాశీలత తక్కువగా ఉంటుంది మిగతా ఫస్ట్ గ్రూప్ మూలకాలతో మనం పోల్చి చూసినప్పుడు. సో ఇవన్నీ కూడా వీటి యొక్క ఫిజికల్ ప్రాపర్టీస్, భౌతిక ధర్మాలు అంటారు. నెక్స్ట్ we shall see the chemical properties of these S block elements. Before going to start the chemical properties, first we shall see the anomalous behavior of lithium. ఈ గ్రూపులో ఉన్నటువంటి మూలకాల్లో ఫస్ట్ది అయినటువంటి లిథియము కొన్ని స్పెషల్ ప్రాపర్టీస్, అంటే మిగతా మూలకాల కన్నా కొన్ని విభిన్నంగా ఉంటుందట. ఏంటి ఆ స్పెషల్ ప్రాపర్టీస్ అంటే ఇప్పుడు మనం చూద్దాం. ది ఫస్ట్ పాయింట్ వచ్చేసి లిథియం ఈజ్ వెరీ స్మాల్ ఇన్ సైజ్ బికాజ్ ఇట్స్ అటామిక్ నెంబర్ ఈజ్ ఓన్లీ 3. సో ఇట్స్ ఎలక్ట్రాన్ కాన్ఫిగరేషన్ ఈజ్ 1s2 2s1 only. So this electron is very near to the nucleus. That's why nuclear attraction is more on this electron. That's why we can't remove this electron quickly. That means high ionization energy is required. That means it is least reactive. ఆ విధంగా మనం ఏమని చెప్పొచ్చు అంటే దీని యొక్క చర్యాశీలత తక్కువగా ఉంటుంది అని. బికాజ్ ఆఫ్ ఇట్స్ స్మాల్ అటామిక్ సైజ్ అండ్ హై ionization energy, small size and high IP. It has high hydration energy also, high hydration energy. Because of its high hydration energy, its salts are hydrated. For example, LiCl2H2O. లిథియంకి దీని యొక్క పరిమాణం తక్కువగా ఉండటము మరియు అధిక అయనీకరణ శక్తి ఉండటం వలన మరియు హై హైడ్రేషన్ ఎనర్జీ ఉండటం వల్ల ఇవి నీటి అణువులతో కలిపి ఇలాగా అణువుల్ని ఏర్పరుస్తుంది అనమాట. అందువల్ల మనము వీటి యొక్క క్లోరైడ్స్ని లేకపోతే వీటి యొక్క సాల్ట్స్ని ఎలాగా చూపించవచ్చు అంటే LiCl2H2O. నెక్స్ట్, బికాజ్ ఆఫ్ ఇట్స్ స్మాల్ సైజ్ అండ్ హై IP and high hydration energy it reacts water with less vigorously. It reacts water with reaction with water less vigorously. Next, it has high polarizing power. Polarizing power మనం ఎలాగ చెప్తాము అని అంటే ఇట్ హ్యాస్ హై పోలరైజింగ్ పవర్. పోలరైజింగ్ పవర్ ఎలా చెప్తామంటే ఛార్జ్ టు రేడియస్ రేషియో. ఈ ఛార్జ్ టు రేడియస్ రేషియో అనేది దాని యొక్క పోలరైజింగ్ పవర్ని రిప్రజెంట్ చేస్తుంది. ఈ పోలరైజింగ్ పవర్ అనేది లిథియంకి ఎక్కువగా ఉంటుంది. సో బికాస్ ఆఫ్ దిస్ హై పోలరైజింగ్ పవర్ it indicates that these compounds of lithium are mostly covalent in character, and this is the responsible for their soluble in organic solvents. దీనికి పోలరైజింగ్ పవర్ ఎక్కువగా ఉండటం వల్ల లిథియం ఏర్పరిచేటువంటి సమ్మేళనాల్లో లిథియంకి సమయోజనీయ బంధ యొక్క లక్షణాలు ఉంటాయి. ఆ సమయోజనీయ బంధం ఉండటం వల్లనే వీటి యొక్క సమ్మేళనాలు కార్బన్ సమ్మేళనాల్లో కూడా కరగగలుగుతున్నాయి అన్నమాట. So because of their high polarizing power, their covalent character increases. Because of this covalent character, these compounds are soluble in organic solvents. So to soluble in organic solvents, its covalent character is criteria. And how to get that covalent character means it is getting its covalent character because of its high polarizing power. Because of this high polarizing power, its compounds are soluble in organic compounds. This polarizing power increases its covalent character, and that covalent character is responsible for its solubility in organic solvents. Next, and when it is placed in towards atmosphere, or when it is exposed to atmosphere, this lithium metal, it takes the oxygen from the atmosphere and it forms lithium oxide. Not only lithium oxide, this lithium, it also takes nitrogen from the atmosphere and it forms a lithium nitride also. It forms the lithium nitride also. So, whereas the remaining elements, they form oxides and peroxides also, whereas the lithium, it forms lithium oxide, and not only that, it also combines with the nitrogen from the atmosphere and it forms the lithium nitride. And not only that, compared to remaining carbonates, this lithium carbonate, I'm sorry, not lithium carbonate, lithium nitrate, on exposed or on heating, lithium nitrate on heating, it forms lithium oxide also, in addition to nitrogen dioxide and oxygen. In addition to nitrogen oxide and oxygen. Whereas the remaining nitrates of this group, on heating, they release only NO2 and O2. They release only nitrogen dioxide and oxygen. But unlike other element nitrates, this lithium nitrate on heating, in addition to nitrogen dioxide and oxygen, it also forms lithium oxide. This is also one of the exceptional behavior of this lithium element. So it shows all these points in its anomalous behavior. One more point is that it also dissolves in ammonia and it forms lithamide solution. It forms lithamide solution. So these are the exceptional behavior of this lithium element. And next we shall discuss the chemical properties of chemical properties. Shall discuss the chemical properties of first A group elements. The order of their reactivity is lithium, sodium, potassium, rubidium and cesium. This is the order of their reactivity, and all are highly electropositive. All are highly electropositive elements. That means they enter into reactions by giving off their one electron present in the outermost orbit. By giving off their ns1 electron, they enter into reactions, so they act as a highly reducing agent, and their order is like this. Lithium is least reactive, next sodium, next potassium. That means cesium is the most reactive one and lithium is the least reactive one. And next, almost all these metals respond to oxidizing flame and they give different colors. and then when they expose it to air, they form oxides. For example, sodium with oxygen. Of course, lithium already forms lithium oxide. Lithium with oxygen, it forms lithium oxide only. This is lithium oxide. The sodium, in presence of excess of insufficient, in presence of limited supply of oxygen, in presence of limited supply of oxygen, sodium forms sodium oxide. Sodium forms sodium oxide. Whereas in excess of oxygen, sodium forms sodium peroxide. Sodium forms sodium peroxide, Na2O2. And the remaining elements, almost all, M indicates alkali metal. The remaining elements with oxygen, they form superoxides. Superoxides general formula is MO2. If it is potassium, this is KO2, potassium superoxide. And like that they form the oxides. Now first we shall see the sodium peroxide. What is its nature? Sodium peroxide is white. Sodium peroxide is white amorphous substance. This is white amorphous substance. This is white amorphous substance, and it dissolve in water and it forms sodium hydroxide. It dissolve in water and it forms sodium hydroxide. That means alkali metal oxides are also basic in nature. That's why these are called alkali metals. So the sodium peroxide, sodium oxide, when dissolved in water, it forms a sodium hydroxide. And this sodium oxide, it also dissolves in ammonia and it forms sodamide and NaOH. It also dissolves in ammonia and it forms sodamide and ammonia. And what is the use of this sodium oxide? What is its use? Means it is used as a dehydrating agent. Dehydrating agent in organic chemistry. Sodium oxide is used as a dehydrating agent in organic chemistry. The next we shall see about sodium peroxide. Sodium peroxide, Na2O2. What happens when it dissolves in water? Means sodium peroxide, when it dissolves in water, it forms, if it is diluted one. And what will happen when it is concentrated? So it gives different products. It forms NaOH and it liberates H2O2. And here it forms also NaOH and here it liberates O2. Liberates O2. Sodium peroxide, when reacts with water, it forms sodium hydroxide and hydrogen peroxide. If it is diluted well with a concentrated solution, it forms sodium hydroxide and oxygen. So then next, what is its use? It is used for the production of oxygen under the name oxone. It is used for the production of oxygen under the name oxone. Next, sodium peroxide. The next, what happens when potassium oxide is dissolved in water? It also forms potassium hydroxide. That means the solution is basic in nature. So all oxides or hydroxides of these alkali metals dissolved in water, they release hydroxyl ions. That's why these are called alkali metals. So potassium oxide, when dissolved in water, it forms potassium hydroxide, which is alkaline in nature. The next, this is called potassium superoxide, KO2, potassium superoxide. And what is its use means? It is used for as an oxidizing agent and also for air purifier. Air purifier means ఎక్కడన్నా ప్లేస్లో ఉన్నటువంటి గాలిని ప్యూరిఫై చేస్తానికి దీన్ని వాడతారు KO2ని. ఎందుకంటే ఇట్ రిమూవ్స్ ద వేస్ట్ ఆర్ వేస్ట్ గ్యాసెస్ అండ్ ఇట్ సప్లైస్ ఆక్సిజన్. దట్స్ వై దిస్ ఈజ్ ఆల్సో యూజ్డ్ ఇన్ మాస్క్. మాస్క్ పెడతాం చూడండి, మాస్క్లో కూడా పొటాషియం సూపర్ ఆక్సైడ్ని వాడతారు. ఇట్ రిప్లేసెస్ CO2 అండ్ ఇట్ ప్రొడ్యూసెస్ oxygen. That's why this is used as a air purifier. It supplies oxygen gas. The next, when it is exposed to air, it forms oxides, and the next its reaction with the water. Next, its reaction with the water. Reaction with water. When reacts these elements with water, with the general example I am showing here. Here M indicates alkali metal. When it reacts with water, it forms MOH and it releases H2. MOH and it releases H2. M is the alkali metal. Suppose M is sodium. Sodium with H2O, it forms sodium hydroxide and H2. That means these are all alkaline in nature. So oxides are when these metals dissolve in water, all are producing hydroxides, means these solutions are alkaline in nature. Next, reaction with water. Then next, reaction with halogen. Reaction with halogen. They react and they form halogens of the type MX. Here M indicates alkali metal and X is the halogen. The general formula for alkali metal halide is MX. Here M is first A group element and X is the halogen, either fluorine, chlorine or bromine, etc. Either chlorine or bromine. And there almost all these are ionic in nature. Usually these alkali metals form ionic compounds. So all these are ionic in nature. Lithium chloride, sodium chloride, potassium chloride, rubidium chloride and cesium chloride. The order of their ionic nature increases in this order. Their ionic nature increases in that order. And then next, reaction with sulfates. They form sulfates of the type M2SO4. M is the first A group element and it forms lithium sulfate and sodium sulfate and potassium sulfate and rubidium sulfate and cesium sulfate. All these are ionic in nature. Their ionic nature also increases in this order. Their ionic nature increases in this order. So like that they form, they react with water and they react with halogens and with acids they form the salts, like the general formula M2SO4. They form the sulfates like that, and they form the nitrates with the general formula MnO3. M1O3 is the general formula. When these nitrates on heating, they are converted to nitrites, Na, so Na, NO2 and O2. Sodium nitrate on heating, it is converted to sodium nitrite. This is called sodium nitrite and release oxygen. And almost all this form, like these are all the chemical properties of first A group elements. And coming to that uses, the first and use of lithium is lithium in the form of alloy. It is used mainly lithium with lead metal. It is used as a white metal and it is used to prepare bearings in motor engines. And lithium with magnesium alloy, it is used to prepare armor plates. And then next coming to sodium. Sodium also used not directly in the form of its compounds, and sodium lead alloy. Sodium with lead alloy used in the preparation of tetraethyl lead, Et 4 times. This is called tetraethyl. Et4 means tetraethyl. Et means ethyl group, C2H5. Et means ethyl group, C2H5. So, in the preparation of tetraethyl lead, sodium is used, and again this is used as anti-knock in petrol. This substance is used as anti-knock in petrol. The next, not only that, cooled sodium is used in the nuclear reactors. So these alkali metals in first A group elements we discuss, and all these are metals only, and the last one is francium is only the radioactive element, because of their as their outer electron configuration is NS1, they immediately release that S1 electron and they enter into chemical reactions, so they act as highly reducing agents. So once again the summary I am giving, and almost all these metals give color in the flame, and lithium gives crimson red color, sodium yellow color, and the remaining elements gives relating to violet color. And almost all these elements, the oxides of these elements, when dissolved in water, they release hydroxide ions in the solution. So these are alkali in nature, and they, when exposed to air, they form oxides, peroxides, and superoxides also. And with halogens, they form the halides of the type MX, and sodium chloride, cesium chloride, like that they form the halides. The ionic nature of these halides increases in this following order, and with they form the sulfates of with general formula M2SO4, and the sulfates are also there, the ionic nature increases in this order. So lithium sulfate is the least ionic, and they also form the nitrates of the general formula MnO3, and this sodium nitrate on heating, it forms sodium nitrite and releases oxygen. అంటే ఈ నైట్రేట్లని వేడి చేసినప్పుడు NO2 గ్యాస్ని అంటే నైట్రైట్లుగా కన్వర్ట్ అయిపోతున్నాయి. కానీ ఒక్క లిథియం నైట్రేట్ మాత్రము హీట్ చేసినప్పుడు నైట్రైట్తో పాటు అది లిథియం ఆక్సైడ్ను కూడా ఏర్పరుస్తుంది. సో అదొక ఎక్సెప్షనల్ బిహేవియర్. లిథియం కొన్ని ప్రత్యేకమైన ధర్మాలు చూపించడంలో అది కూడా ఒక ప్రత్యేకమైనటువంటి క్యారెక్టర్. అండ్ దెన్ నెక్స్ట్ ఈ విధంగా మనకు కెమికల్ ప్రాపర్టీస్ చూపిస్తాయి. అండ్ కమింగ్ టు దేర్ యూజెస్, మనకు యూజెస్ వచ్చేసి లిథియం వచ్చేసి మెయిన్గా ఎలాయిస్ అంటే ఏంటి, మిశ్రమ లోహాలు తయారీలో లిథియంని యూజ్ చేస్తారు. లిథియంను లెడ్ కలిపి ఒక ఎలాయ్ అంటారు, దాన్ని ఏమంటారంటే వైట్ మెటల్ అంటారు. ఈ వైట్ మెటల్ని ఎక్కడ యూజ్ చేస్తారంటే ఇట్ ఈజ్ యూజ్డ్ టు ప్రిపేర్ బేరింగ్స్ ఇన్ మోటార్ ఇంజిన్లో బేరింగ్ ఉంటుంది, దాన్ని ప్రిపేర్ చేయడంలో యూజ్ చేస్తారు. దెన్ నెక్స్ట్ లిథియం మెగ్నీషియంతో కలిపి మనకు ఆర్మార్స్ ఉంటాయి, ఆర్మార్ ప్లేట్స్ ప్రిపేర్ చేయడంలో కూడా దీన్ని యూజ్ చేస్తారు. సో ఈ ఫస్ట్ ఏ గ్రూప్ ఎలిమెంట్స్లో మనకు ప్రస్తుతానికి సిలబస్లో ఇంతవరకు ఉన్నాయి. ఇప్పుడు 30% సిలబస్ రిమూవ్ చేయటం వల్ల మనకు కొన్ని కాంపౌండ్స్ ఉండేవి, సోడియం హైడ్రాక్సైడ్ అని, సోడియం కార్బోనేట్ అని, సోడియం బైకార్బోనేట్, ఇవి ప్రస్తుతానికి సిలబస్లో 30% సిలబస్లో రిమూవ్ చేశారు. సో మనకు ఇక రిమైనింగ్ టాపిక్స్లో ఈ ఫస్ట్ ఇయర్ ఎస్ బ్లాక్ ఎలిమెంట్స్లో ఫస్ట్ ఏ గ్రూప్ ఎలిమెంట్స్లో ఇవి మాత్రం ఉన్నవి. జస్ట్ ఐ టోల్డ్ యు నో ద ఇంట్రడక్షన్. Then next general chemical properties and their physical properties, chemical properties. And in chemical properties లో మెయిన్గా ఇవి ఎలాగా ఆల్కలీ నేచర్ అనే విషయం మీద మీకు 2 మార్క్స్ క్వశ్చన్స్లో అడుగుతూ ఉంటారు. when these oxides dissolve in water, they form hydroxides. సో దే ఫామ్ హైడ్రాక్సైడ్స్ మీన్స్ ఎప్పుడైతే అవి హైడ్రాక్సైడ్ ఏర్పరుస్తున్నాయో దాన్ని బట్టి అవి ఆల్కలీ నేచర్ ఉంది, వాటికి క్షార స్వభావం ఉన్నది అని చెప్తాం. అందువల్ల వీటిని ఏమన్నారంటే క్షార లోహాలు. ఫస్ట్ ఏ గ్రూప్ మూలకాలకు మరొక పేరేంటి, క్షార లోహాలు. ఇవన్నిటికి కూడా లోహాలే, కాకపోతే వీటికి క్షార స్వభావం ఉంటుంది. జనరల్ పాయింట్ కూడా ద ఆక్సైడ్స్ ఆఫ్ మెటల్స్